going to start this section by exploring comparison operators. We use comparison operators to compare values. Here are a few examples. So 10 is greater than 3. We get true. So what we have here is a Boolean expression. Because when this expression is evaluated, we'll get a Boolean value that is true or false. Here's another example. 10 is greater than or equal to 3. Once again, we get true. We also have less than, so 10 is less than 20. We have less than or equal to. Here's the equality operator, so 10 is equal to 10. What about this expression? What do you think we're going to get? We get false. Because these values have different types and they're stored differently in the computer's memory. And finally, we have the not equal operator. So now with this expression, we should get true. Beautiful. We can also use these comparison operators with strings. Let me show you. So we can check to see if bag is greater than apple. We get true because when we sort these two words, bag comes after, so it's considered greater. Now what about this one? Bag equals capital bag. We get false. Here's the reason. Every character you see here has a numeric representation in programming. Let me show you. So we have this built-in function called ord. Don't worry about memorizing this because you're probably never going to use this in the future. But let me show you the numeric representation of the letter B. So that is 98. In contrast, capital B is represented as 66. That is the reason these two strings are not equal. So these are the comparison operators in Python. Next, we'll look at conditional statements. In almost every program, there are times you need to make decisions, and that's when you use an if statement. Here's an example. Let's say we have a variable called temperature. We set it to 35. Now, if temperature is greater than 30, perhaps we want to display a message to the user. So we use an if statement. If, after if, we add a condition, which is basically a Boolean expression, an expression that produces a Boolean value. So if temperature is greater than 30, here we have a Boolean expression. If this expression evaluates to true, the following statements will be executed. Let me show you. Now here's the important part that a lot of beginners miss. When you use an if statement, you should always terminate your statement with a colon. Now let's see what happens when I press enter. Our cursor is indented. So here we have two white spaces. This is very important because using these indentations, Python interpreter will know what statements should be executed if this condition is true. Here we want to print a message like, it's warm. We can print another message as well, drink water. So we can have as many statements as we want here. As long as they are indented, they belong to this if block. Now, when we finish here, we should remove indentation to indicate the end of this if block. So here we can add a print statement with a message like done. This statement will always be executed whether this condition is true or not. Now, note that when I save the changes, this indentation you see here is going to be doubled up. Take a look. Save. There you go. So when we save the changes, AutoPep8 reformats our code and uses 4 white spaces for indentation. So 1, 2, 3, 4. It uses 4 white spaces because that's what PEP8 recommends. All right, now let's run this program. So because temperature is greater than 30, we see the first 2 messages and we see the done message regardless. So if I change the temperature to, let's say 15 and run the program one more time, look, this done message is executed whether our condition is true or not. So pay great attention to these indentations. That's one of the issues I see in beginners code. Let's say they want both these print statements to be executed if the condition is true. Accidentally, they remove the indentation on the 4th line. And that's why their program doesn't work as they expect. So be careful about this. Now, what if we want to have multiple conditions? We use an elif statement. So elif, that is short for else if. Here we can add another condition, another expression. So temperature is greater than 20. Once again, colon, enter. Now by default here, VS Code is using 2 white spaces. So don't worry about this. As soon as you save the changes, those 2 white spaces will be converted to 4 white spaces. So let's print a different message. It's nice. Save the changes. Now look, all these lines are indented consistently. You can have as many elif statements as you want. And optionally, you can also have an else statement. So if none of the previous conditions are true, then what you have in the else block will be executed. Once again, we add the colon, indentation, print. Here we can add a message like it's cold. Save the changes. In this case, temperature is 15. So none of these 2 conditions will be true, and we will see it's cold. Let's run the program. There you go. In this lecture, I'm going to show you a technique for writing cleaner code. So let's say we're building an application for a university, and we want to check to see if the person who's applying for this university program is eligible or not. So we start by defining a variable called age, set it to 22. Now, if age is greater than or equal to 18, colon, print eligible, remove the indentation, else, colon, print not eligible. Let's run the program. Make sure it works. Beautiful. Now, there is nothing wrong in this piece of code, but I want to show you a cleaner way to achieve the same result. Instead of having a print statement here, we can define a variable like message and set it to this string. That is the first step. So message equals this string. And then we will print this message. Now, when you have an if-else statement with this structure, where you're basically assigning a value to a variable, you can rewrite this in a simpler way. So this is how it works. All we want to do over these few lines is to assign a value to this message variable, right? So we start with message. We set it to eligible if age is greater than or equal to 18, else we set it to not eligible. This statement is almost like plain English. So what we have on line 7 is exactly equivalent to these 4 lines of code. Delete, save the changes, run the program. You can see this person is eligible. If I change the age to 12 and run the program, we get not eligible. So what we have here is called ternary operator. In Python, we have 3 logical operators, and we use these operators to model more complex conditions. So these operators are and, or, and not. Let's see a real-world example of using these operators. So imagine we're building an application for processing loans. So we need 2 variables. High income, we can set this to true, and good underline credit, we set it to true. Now here's the condition we want to implement. If the applicant has high income and good credit score, then they are eligible for the loan. So if high income and good credit, we add the colon and print eligible. Now note that here I have not compared the value of this variable with true. That is one of the issues I see in a lot of beginners code. This is redundant and unprofessional because high income is a Boolean, so it's either true or false. We don't need to compare true with true. So if this condition is true and this second condition is true, then we will print eligible in the terminal. So save the changes and run the program. Obviously, this person is eligible. However, if one of these conditions is false, we will not see eligible in the terminal. So let's add an else statement here and print not eligible. Run the program. We see not eligible. So this is how the AND operator works. With AND operator, if both conditions are true, the result will be true. In contrast with the OR operator, as long as at least one of the conditions is true, the result will be true. So if I replace AND with OR here, we should see eligible in the terminal. Let's run it one more time. There you go. So these are the AND and OR operators. Now let's take a look at an example of the NOT operator. So I'm going to define another variable, student, set it to true. Temporarily, I'm going to remove this expression and simplify it. We'll come back to this later. So let's say if the person is eligible if they are not a student. The NOT operator basically inverses the value of a Boolean. So in this case, student is true. When we apply the NOT operator, the result will be false. So in this case, our condition will be false, and that's why this print statement will not be executed. Let me show you. So save, run the program, they're not eligible. If student was false, when we apply the NOT operator, we'll get true, so our condition will be true and we'll see eligible. Let's run it one more time. There you go. With these operators, we can model even more complex conditions. Here is an example. A person can be eligible if they have either high income or good credit, and they should not be a student. Let me show you how to implement this condition. So, if high income or good credit, we want at least one of these conditions to be true. So, we put these in parentheses. We want to separate these from the other condition, which is not a student. Now, the result of this should be true, which means at least one of these conditions should be true. After that, we'll add and not student. And finally, colon. So with these operators, you can model all kinds of real-world scenarios. So here's the example from the last lecture. A person is eligible for a loan if they have high income and good credit and they are not a student. Now, one thing you need to know about these Boolean operators is that they are short circuit. What do I mean by that? Well, when Python interpreter wants to evaluate this expression, it starts from the first argument. If this is true, it continues the evaluation to see if the second argument is also true. So it continues the evaluation all the way to the end of this expression. However, as soon as one of these arguments is false, the evaluation stops. Let me show you what I mean. So if I change high income to false, when Python interpreter sees this expression, it starts here. It knows that high income is false, so it doesn't matter what comes after. The result of this entire expression will always be false because at least one of the arguments or one of the operands is false. This is what we call short circuiting, just like the short circuit concept we have in electronics. So the evaluation stops as soon as one of these arguments evaluates to false. We have the same concept with the OR operator. So if I change these AND operators to OR, let's see what happens. With the OR operator, we know that at least one of the arguments should be true. So the evaluation stops as soon as we find an argument that evaluates to true. In this case, when Python interpreter evaluates this expression, it sees that high income is false, so it continues the evaluation, hoping that the next argument will be true. Here, good credit is true, so evaluation stops, and the result of this entire expression will be true. So in Python, logical operators are short circuit. In this lecture, I'm going to show you how to chain comparison operators. This is a very powerful technique for writing clean code. Here's an example. Let's say we want to implement a rule that says age should be between 18 and 65. Here's how we can implement it. So we define a variable like age, set it to 22. Now, if age is greater than or equal to 18 and age is less than 65, then we print eligible. Now here's a question for you. How do we write this rule in math? We can write it like this. Well, more accurately, we should have an equal sign here. So age should be between 18 and 65. This is how we write this rule in math. Now, I've got some good news for you. We can write the exact same expression in Python. So I'm going to move this up, put an if statement here. Line 4 and line 3 are exactly equivalent. But as you can see, line 4 is cleaner and easier to read. So let's get rid of line 3. This is what we call chaining comparison operators. All right, here's a little quiz for you. I want you to pause the video and think about this quiz for 10 to 20 seconds. What do you think we'll see on the terminal when we run this program? So pause the video, figure out the answer. When you're ready, come back, continue watching. All right, let's see what happens when we run this program. First, we get this if statement. In this case, we're comparing two different objects for equality, and these objects have different types. We have a number compared with a string. So number 10 and string 10 are not equal. That is why A will not be printed on the terminal. So the control moves to the elif part. Here we have two Boolean expressions. Here's the first one. Here's the second one. And they are combined using the logical AND. So if both these expressions are evaluated to true, then this entire expression will be true and we will see B on the terminal. Let's see if both these expressions are evaluated to true. Here's the first part. Bag is greater than apple. That is true because when we sort these words, bag comes after apple. But look at the second part. This expression is evaluated to false because bag is not greater than cat. So when we apply the logical AND between true and false, the result will be false. That is why this statement will not be executed. So the control moves to the else part. And when we run this program, the letter C will be printed on the terminal. There are times that we may want to repeat a task a number of times. For example, let's say we send a message to a user. If that message cannot be delivered, perhaps we want to retry 3 times. Now, for simplicity, let's imagine this print statement is equivalent to sending a message. In a real-world program, to send a message to a user, we have to write 5 to 10 lines of code. Now, if you want to retry 3 times, we don't want to repeat all that code. That is ugly. That's when we use a loop. We use loops to create repetition. So here's how it works. We start with for, number, in. We have a built-in function called range. Now, how many times we want to repeat this task? Let's say 3 times. So we call range and pass 3 as an argument. Now, similar to our if statements, we need to terminate this line with a colon. Enter, we get indentation. So in this block, we can write all the statements that should be repeated 3 times. Let's do a print, a message like attempt. Save the changes, run the program. So we have attempt printed 3 times, beautiful. Now, what is this number? Let's take a look. It's a variable of type integer. So let's pass it as the second argument to the print function, number. Run the program. This is what we get, 0, 1, 2. So here we have a for loop. This for loop is executed 3 times. In each iteration, number will have a different value. Initially, it will be 0. In the second iteration, it will be 1. And finally, in the last iteration, it will be 2. Now here we can do something fun. We can add 1 to this, run the program, and now the messages that we print are kind of more meaningful or more user-friendly, like attempting number 1, attempting number 2, and so on. We can take this to the next level. So we can pass another argument. Here I'm going to add an expression. One more time, number plus 1. So we'll get 1, 2, 3. Now I want to put this expression in parentheses. So let's select this, put it in parentheses, and then multiply it by a dot. So here we have a string that is multiplied by a number. The result will be that string repeated that number of times. Let's take a look. So run the program. See, that's pretty cool, isn't it? Now let me show you one more thing before we finish this lecture. As you saw, this range function generates numbers starting from 0 all the way up to this number here, but it doesn't include this number. Here we can pass another argument, say start from 1 and finish before 4. With this change, we don't need to add 1 to number every time, because in the first iteration, this number variable will be set to 1. So we can simplify our code and make it cleaner. Let's run it one more time. We get the exact same result. We can also pass a third argument as a step. So I'm going to change the second argument to 10 and pass 2 as a step. Look at the result. These are the numbers we get, 1, 3, 5, and so on. So pretty useful. You're going to use this function a lot in real-world applications. Continuing with the example from the last lecture, let's imagine the scenario where after the first attempt, we can successfully send the message. In that case, we want to jump out of this loop. We don't want to repeat this task of sending a message 3 times. Let me show you how to implement this. So in this demo, I'm going to simulate the scenario where we can successfully send a message. So we define a variable, successful, and set it to true. Now here, after this print statement, we'll have an if statement, if successful, colon, then perhaps we can print successful. Now here we want to jump out of this loop. For that, we use the break statement. Let's run this program and see what happens. So there you go. After the first attempt, we are successful and there are no more attempts. So once again, I want you to pay great attention to the indentation here because that's one of the common issues amongst beginners. So here's our for loop. These 2 lines are indented with 4 spaces and they belong to our for loop. In every iteration, these 2 lines will be executed. Now, when we get to line 4, if this condition is true, then these 2 lines will be executed because both these lines are indented below this if statement. Now, let's take this program to the next level. What if we attempt 3 times and we still cannot send an email? Perhaps we want to display a different message to the user. We say, hey, we tried 3 times, but it didn't work. So I'm going to change successful to false. Now at the end, here we can add an else statement. This is what we call a for else statement. What we put under this else statement will only be executed if this loop completes without an early termination. So if we never break out of this loop, then the else statement will be executed. So here we can print a message like attempted 3 times and failed. So run the program. See what we get. 3 attempts followed by this message, attempted 3 times and failed. In contrast, if we change successful to true, because we terminate this loop using this break statement, what we have in the else block will not be executed. Take a look. Run the program. We have 1 attempt, successful, done. In programming, we have this concept called nested loops. So we can put one loop inside of another loop, and with this, we can get some interesting results. Let me show you. So I'm going to start with this loop for x in range 5, colon. Now, inside of this loop, I'm going to add another loop. So for y in range 3, colon. And then in our second loop, I'm going to add a print statement. Here we can use formatted strings to display coordinates. Remember formatted strings? So we have f followed by quotes. Now here we add parentheses for our coordinates. First, we want to display x and then comma followed by y. Let's run this program and see what happens. There you go. Pretty cool, isn't it? So we get 0 and 0, 0 and 1, 0 and 2. Then we get 1 and 0, 1 and 1, 1 and 2, and so on. Now let me explain how exactly Python interpreter executes this code. So here we have 2 loops. This is what we call the outer loop, and this is the inner loop. So the execution of our program starts here. In the first iteration of this loop, x is 0. Now we get to this statement, which is a child of this for statement because it's indented 4 times. This statement itself is a loop. So what we have inside of this loop will be executed 3 times. In the first iteration, x is 0 because we're still in the first iteration of the outer loop. And y is also 0 because we're in the first iteration of the inner loop. That is why we get 0 and 0. Now we go to the second iteration of this inner loop. In this iteration, y will be 1, whereas x is still 0. That is why we get 0 and 1. And similarly, in the third iteration of our inner loop, we'll get 0 and 2 in the terminal. Now we're done with the execution of the inner loop, so the control moves back to our outer loop. Here we'll be in the second iteration, so x will be 1, and then we start here again. So we have to execute this inner loop 3 times. In the first iteration, y will be 0 and x is 1. So here we have 1 and 0, then we'll get 1 and 1 and 1 and 2. You got the point. So this is all about nested loops. So you have learned how to use for loops to repeat one or more statements in your programs. Now let's dive deeper and see what this range function returns. So earlier you learned about the built-in type function. With this function, we can get the type of an object. So if I pass 5 here and run this program, this is what we get. So the type of this number or this object is int or integer. Now let's look at the type of the value that we get from the range function. So as an argument, we pass range of a number. Let's run this program. So this range function returns an object of type range. So in Python, we have primitive types like numbers, strings, and booleans, but we also have complex types. Range is an example of one of those complex types. Throughout this course, you're going to learn about a lot of other complex types. Now, what is interesting about this range object is that it's iterable, which means we can iterate over it or use it in a for loop. That is why we can write code like this. So this range function returns a range object which is iterable, which means we can iterate over it. In each iteration, x will have a different value. Now, range objects are not the only iterable objects in Python. Strings are also iterable. So here we can add a string like Python. Now in each iteration, x will hold one character in this string. Let me show you. So print x, and I'm going to delete these 2 lines here. Let's run this program. So in each iteration, we'll get one character and print it. We have another complex type called list, which we use to store a list of objects. So we add square brackets. This indicates a list. Now we can add a list of numbers or a list of strings, like a list of names. You will learn about lists later in the course. So let's run this one more time. As you can see, we can iterate over lists. In each iteration, we'll get one object in this list. Now later in the course, I will show you how to create your own custom objects that are iterable. For example, you will learn how to write code like this. For item in shopping cart, print item. So shopping cart is going to be a custom object that you will create. It's not going to be an integer or a string or boolean. It's a custom object. It has a different structure. And we'll make it iterable so we can use it in a for loop. And in each iteration, we can get one item in the shopping cart and print it on the terminal. So you have learned that we use for loops to iterate over iterable objects. In Python, we have another kind of loop that is a while loop. And we use that to repeat something as long as a condition is true. Here's an example. So let's define a variable number and set it to 100. Now we use while, and here we add a condition. As long as number is greater than 0, we add a colon. Once again, we have indentation, so we can repeat one or more statements. We can print this number, And then we can divide it by half. So number equals number. Use the integer division to divide it by 2. Or we can use the augmented assignment operator to shorten this code, like this. Now let's run this program. So here's what we get. Initially, our number is 100. We divide it by half. We get 50, then 25, and so on. So as you can see, in this example, we are not iterating over an iterable like a range object or a string or a list. We are evaluating a condition and repeating a task. Let me show you a real-world example of a while loop. In this interactive shell, Python is waiting for an input. We can type something like 2 plus 2. It will evaluate it and ask for the next input. We can add another expression like 10 is greater than 2. So these steps will continue until we press Ctrl D. So behind the scene, we have a while loop that continues execution until we press Ctrl D. That is the condition that causes the while loop to terminate. Let me show you how to build something like this in Python. So let's define a variable, command, and set it to an empty string. Now, here we need a while loop. We want this while loop to execute as long as command does not equal to quit. So command does not equal to quit. Colon. In this loop, we want to continuously get input from the user. So we use the built-in input function. We add a label like this, get the result and store it in the command variable. Now at this point, Python interactive shell will evaluate this command. We are not going to do that in this lecture because that's way too complex. For simplicity, we can just echo back what the user entered. So print echo, and as the second argument, we pass this command. So this is our while loop. It will execute until we type quit. Now, as I told you before, don't run this program using the code runner extension because by default, it will run your program in the output window, which is read only. So open up the terminal using Control and backtick and run Python or Python 3 app.py. So here's our command prompt. Let's type 2 plus 2. It echoes back. Let's type 3 times 2. There you go. If we type quit, our program terminates. Now let's try it one more time. What if we type quit in uppercase? The program doesn't terminate because as you learned before, lowercase and uppercase characters have different numeric representations. So quit in lowercase is different from quit in uppercase. Now to solve this problem, an amateur programmer may do something like this. And command does not equal to capital quit. So while command does not equal quit in lowercase and quit in uppercase, continue getting input from the user. Let's run this program in terminal and see what happens. So one more time, Python app.py. We type quit. Beautiful, it works. We type quit in uppercase. That would work too. But what if I type quit with an uppercase Q and lowercase UIT? Our program doesn't terminate. So this is a poor way of checking for the quit command. What is a better way? Let me show you. So we don't need this AND operator here. Instead, because command is a string, we can call the lower method. So whatever the user types in, first we'll convert it to lowercase and then compare it with quit in lowercase. With this change, it doesn't matter how the user types the word quit. We'll always terminate the program. Now, the last thing I want to discuss in this section is the concept of infinite loops. An infinite loop is a loop that runs forever. So if I change this condition to true, because true is always true, this while loop will run forever. So to jump out of this, we need a break statement. So after we get the input from the user, we can get the command, convert it to lowercase, and see if it equals to quit. If that's the case, we want to break. Now with this change, we no longer need to initialize command to an empty string. Previously we needed this Because we had a while statement like this. While command does not equal quit. So we had to define this command variable, and that's why we have set it to an empty string. Without this line, when Python interpreter tries to execute this code, it doesn't know what command is. So now that we have an infinite loop, we no longer need to define command and set it to an empty string. So in terms of functionality, this program is exactly the same as the program we wrote in the last lecture. Just be aware of these infinite loops. Because they run forever, you should always have a way to jump out of them. Otherwise, your program will run forever. And this can sometimes cause issues because if you're executing operations that consume memory, at some point your program may run out of memory and crash. All right, time for an exercise. I want you to write a program to display the even numbers between 1 to 10. So when you run this program, you should see 2, 4, 6, and 8. And after these, I want you to print this message. We have 4 even numbers. Now here's a quick hint before you get started. You should call the range function with 1 and 10. Do not use the third argument, which is called step. So basically, I want you to iterate over all the numbers between 1 to 10. Check if each number is an even number and then print it on the terminal. So pause the video, spend 2 minutes on this exercise. When you're done, come back, continue watching. So we start with a for loop for number in range 1 to 10, colon. We check to see if the remainder of division of this number by 2 equals 0. So if number modulus 2 equals 0, then we print this number. Now let's run this program. So we get 2, 4, 6, 8. Beautiful. Now to count the even numbers, we need a separate variable. So let's call that count. Initially, we set it to 0. Now in this if block, every time we find an even number, we need to increment count. So we set count plus equals 1. And finally, after our for loop, we can print a formatted string. We have count even numbers. Let's run the program, and here's the result. So that brings us to the end of this section. In the next section, you're going to learn how to create your own functions. I hope you enjoyed this section, and thank you for watching.